So the last question, 66. Which of following subset are subrings of the ring of the real integer, real numbers? So subring. So subring need to be closed. Sorry. So basically, subring is as with plus is additive subgroup, and also as is closed under multiplication. This forms a subring. Okay, so the first one is the q square root of 2. It's obvious this is subring of R. This can be verified easily because you add two number. Basically, because q square root of 2 is a field. So basically, the addition and multiplication are already close. So the first one is simple. Okay, so the difficult, probably the difficult one is the second one. It say that an integer divided by non-negative integer, n divided by 3m. So how about we try to see whether it is addictive. We can change it to okay. So you see for this one, this is additive close. This is close in additive. And so also we have the inverse. Inverse is the same. It is minus n1 divided by 3m1. And then we have the identity. So identity is 0. So basically, the second is in addition is the group. And then we check the multiplicity. The multiplicative should be close. So we need to check whether it's close or not. So we can times two element, and it's obviously that it's close. So we show that the second is a subring. So the first one and second one is correct. How about third one? AB square root of 5 and AB are reals. Square plus b square is more than 1. Okay, so this is not a subgroup because you can use 1 plus square. I choose A to be 0, I choose A to be 1, B to be 0, then we have 1 belongs to 3, and if we times, if we use 1 plus 1, then it's 2. So 2 cannot be written as 1 plus b squared root of 2. A squared plus b squared is more than 1. So basically, the third space is not, the third set is not additive subgroup. So the answer is the first one and the second one. The answer is B. The answer is B.